Hey everybody, it's me, I'm back. I tried to put some music on there for you, but there's no music this time because I didn't want the thing to screech again. So instead I'm going to just put cute little pictures. So as you can see, here we have Super Squirrel, and Super Squirrel is saying that I'm super and you can be too if you watch this video. Now here's a warning. The problems in this review may be a little different than the review that you have, so I am going to leave a blank copy of this review that I'm writing from on Edline, as well as the copy of the answers, as well as this video. Alright? So good luck, and I hope that this helps. Alright, first question, number 1, we did in class. And it's a piecewise. So every time you see a piecewise, you always have to make two tables. First table is going to go from 1, 2, and 3, because greater than means more than. So if it's more than, we need to include 1, then 2, then 3, etc. The 1 is going to have a closed circle when we actually graph it. So, negative of 1 plus 2 is 1. Negative of 2 plus 2 is 0. And negative of 3 plus 2 is negative 1. Now, when you graph it, you're going to go to 1, 1 first, make a closed circle, 2, 0, 3, negative 1. Since it's more than always goes to the right, so our graph should continue in the right direction. The next table is for less than. Less than means smaller than. So I need numbers that are smaller than 1. So 1, 0, negative 1, etc. And this graph should go to the left. So then I plug in my numbers. 3 times 1 plus 4 is 7. 3 times 0 plus 4 is 4. And 3 times negative 1 plus 4 is 1. So these are numbers that you can also plug into your calculator. So 1, 7 is all the way up here. 0, 4. Negative 1, 1. And my graph should go to the left. Alright, so now for my property questions. Domain, remember domain is your whole entire x-axis. And what are the numbers doing? Well, I see that the graph on the left-hand side, this one, is constantly going to the left. Then I look on the other side and see that the other side's graph is constantly going to the right. So because they're going in both directions forever, I say that my domain is all real numbers, which is from negative infinity to positive infinity. The range is how low and how high does this graph go. Well, if I look to the lowest part, I see that the graph is going lower and lower all the way to negative infinity. Then I see here that it stops, kind of. So because it starts down at negative infinity and goes all the way up to almost hitting 7, I would say negative infinity to 7 with a parenthesis. This open circle means that I should always have parentheses. The closed circle here means that you're going to have a bracket. So continuity? No. Because of this break going from here to here. Maximum value? Well, normally we would think it's 7, but what's happening is this graph is going up, 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 and it's getting closer and closer and closer, and then it stops here close to 7, but it doesn't actually stop at 7 because this is not a closed circle. It's an open circle. So we would say we have no maximum value. And that's because of the open circle at 7. So we can't value something that it doesn't stop at. We can't measure that. There's no minimum value because the arrows are pointing down to negative infinity, so there's none. Alright, now for increasing and decreasing interval. I know that you guys are really confused by this sometimes, but you have to remember to think horizontally, not vertically. Now, when we think about a graph increasing or decreasing, we always think in terms of up or down. But an interval basically is saying, what x values am I using to make this graph grow? Or what x values am I using to make this graph get smaller? So if I look here and I evaluate all of these x values, this graph is increasing. And I need to know what are all of these x values that I'm using to make this graph increase. Well, here I'm at 1, then this value is 0, then this value is -1, then this value is -2. So what happens is the x values are getting smaller and smaller, and eventually they will hit negative infinity. Well, when your graph is getting smaller to negative infinity, that means that if we are thinking from left to right, we have to change this order. So really, this graph is starting at negative infinity and it keeps going to the right until it hits 1. You always have to think left to right for your intervals. So we started at negative infinity, ended at 1 with an open circle. So remember, those are parentheses. So our increasing interval is, negative infinity to 1. Now on the other side, our graph is decreasing. I know it's decreasing because it's sliding down. You have to imagine like you're sliding down a hill. And the x values that I'm using from here start at 1, then 2, then 3, then 4, then 5, then 6, all the way to infinity. So these are, if you think horizontally, it's starting at 1 and then going all the way to the right to infinity. Because that's a closed circle, I'm going to need a bracket. So bracket of 1 to infinity. Alright, it is definitely not 1 to 1, because if I draw a horizontal line, it hits it in 2 spots. So it's not 1 to 1. And there's no axis of symmetry, because axis of symmetries are only for parabolas and absolute values. Alright? Alright, we see Super Squirrel again. Hello, Super Squirrel. And in this one, Super Squirrel says, you can do it. Alright, so if we look here, we have bars. Every time you have bars, those bars mean that you are going to have an absolute value graph. So an absolute value graph has two things, an A value and a V value. So the A value would be -1/2. It's always the number that's in front of the bars. Your V graph would be opposite of the inside. Second number stays the same. So your V would be 2, -4. Now to graph it, you're going to transform it from the middle, going right 2 and down 4. That is your vertex. That is your starting point. So now from there, because if A is negative, we're going to go down 1 and over 2. Down 1 over 2. Down 1 over 2. Since this is not a straight line, this is an absolute value, we have to reflect it on the other side, going down 1, left 2. Down 1, left 2. Okay, and then I'm going to connect the dots. Now I just realized that Your review does not have a negative in front. So because your review is a little different than the review that I have online, just remember that if it's negative, you go down. Since your review has a positive, we're going to go up. Remember I told you that the review that I have for you is different than the one I have on this flip chart, so just bear with me. Alright, so you know that we're going all the way to the right, all the way to the left. So since we're going all the way to the right and left, that means that our domain goes from negative infinity to positive infinity. For our range, we start here at, looks like 4, and then we just keep going up and up and up and up to infinity. So that means that it goes from negative 4 up to infinity. Continuities, yes, because I never have to pick up my pen when I'm going around it. We have no maximum value because infinity is not something you can measure. But you can measure negative 4. Alright, now for the intervals. So if we look horizontally from left to right on this increasing part of the graph, so it's increasing right here. What x values am I using? So remember, these are x values. Looking from left to right. What x values am I using to make this increase? So I start off here with 2. Then this side is 4. Then this is 6. Then we're probably going to go to 8. And all the way to the right to infinity. So my increasing interval starts at 2 and goes to infinity. Now if I go on the left-hand side, here, this is my decreasing interval. So that means here I'm at 0. This point is negative 2. Then negative 4. Then negative 6. Looks like the numbers are getting smaller as I go to the left. So that means I must have started with a really small value of negative infinity. So it goes from negative infinity all the way to 0, to 2. So that means that my increasing interval is negative infinity to 2. It is not 1 to 1 because it doesn't pass the horizontal line test. Axis of symmetry is only for parabolas and absolute value graphs. Well, this is an absolute value graph. So that means the axis of symmetry will be that line that cuts right through the middle of the graph. Notice that it cuts through at 2 because it cuts through here at x equals 2. So that means the name of this line is x equals 2. With axis of symmetry, that's a line. So don't forget the x equals. Okay, that's very, very important. Alright. Okay, on to the next one. Alright, another graphing question. And Super Squirrel says, I love graphing. And I love graphing too, Super Squirrel. So if you notice that there's a negative on this version of my review, just ignore the negative. Alright, another absolute value graph. So we're going to do the same thing. A equals 1. B equals 3, 4. So we're going to go to 3, 4 on our graph. So go transform your graph going right 3, up 4. And you know it's going to face up, going up 1, over 1. This is not a straight line because of these bars, so it is a V graph. Alright, our domain is going to be the same thing, from negative infinity to positive infinity. Our range is as low as 4 and goes to infinity. It is continuous because I never have to pick up my pen to go around the graph. There is no maximum value because remember, infinity is something you cannot measure. 4 is the smallest value. Our increasing interval starts here. Remember, you're not starting at 4, you're actually starting and looking left to right, you're starting at 3. And you're going from 3 all the way out to infinity. So your increasing interval is from 3 to infinity. That means you must be looking on the other side to negative infinity for the decreasing interval. So that starts at negative infinity and stops at 3. Remember, this is x. It is not one-to-one because it doesn't pass the horizontal line test, and there is an axis of symmetry. Notice that this green line here goes through the x-axis and it crosses the x-axis here at x equals 3. So that is the name of our line. Remember, axis of symmetry is only for parabolas and absolute value graphs. And it's the line that cuts through the middle. Alright, number 4 on my paper looked different than yours, so I changed it a little bit. And once again, we have our friend Super Squirrel, and he says, I'm nutty about math. So, that's so cute, Super Squirrel. Anyway, we have 2 things here. That means it's a piecewise. So you make your 2 xy tables. Since that's 3 and it says less than, that means we're going to wind up going to the left, and we need numbers that are smaller than 3. So I'm going to go with 3, 2, 1. Now on the other side, this says greater than, we're going to wind up going to the right. We need numbers that are larger than 3. So numbers that are larger than 3 would be 3, 4, 5. But because there's a 5 here in the denominator, I want to pick numbers that can be divided by 5. So I have to start with 3 because I need an open or closed circle. But the next number, I don't have to go to 4. I can skip to 5 because that denominator is 5. And then I can skip to 10. So you always want to go by what numbers can be divided into that denominator. Alright, first one, so we have negative 2 times 3 plus 4. That equals negative 2. Negative 2 times 2 plus 4. That equals 0. And negative 2 times 1 plus 4. That equals 2. Alright, on the other side, 2/5 times 3 plus 2 gives us a decimal. That equals 3.2. 2/5 times 5 plus 2. Well, 2 times 5 is 10. 10 divided by 5 is equal to 2. So 2 plus 2 equals 4. 2/5 times 10 plus 2. 2 times 10 is 20. 20 divided by 5 is equal to 4. So 4 plus 2 equals 6. So when you use numbers that are divisible by that denominator, it makes it really easy for you to find the answers. Because if not, you're going to have a whole bunch of decimals to deal with. Alright, now for the graph. First thing we're going to do is go to 3, negative 2. Make a closed circle. Then we're going to go to 2, 0. And then 1, 2. Now, since we're supposed to be going to the left, we're going to connect our dots to the left. Remember, it's always good sometimes to have a highlighted line here, so you know that one of your graphs is to the left and the other graph is to the right. Alright, the next one is 3 and 3.2. Well, 3.2 is actually going to be somewhere in between 3 and 4. So I need to go like right in the middle somewhere for 3.2. Now I'm going to go to 5, 4. And then 10, 6. So that's going to be all the way over here. Not a lot of room. And I'm probably going to run into Super Squirrel. Sorry, Super Squirrel. Alright, so I have one graph going to the right, one to the left. Alright, if I notice, both graphs are going to the left in both directions. This is going all the way to the left. This is going to the right in both directions. So my domain is all real numbers. My range stops here. This is my lowest point of my range. So since that's my lowest point here at -2, it winds up shooting up on both sides to infinity. So my range is from -2 to infinity. There is no continuity because there's a break. The maximum value, there is none because they both go to infinity. Since this is a closed circle, my minimum value is 2. When you have a closed circle, you do have a minimum value. If this was open, we would not have one. Alright, increasing. This seems to be the only graph that's increasing. So it starts here at 3, then it goes to 5, and then we went all the way to 10, and then it's probably going to go on forever. So horizontally, because remember we are looking horizontally for intervals, horizontally it goes to the right forever. So that means that it goes from 3 to infinity. And I use a parenthesis because there's an open circle. So open circles get parentheses. The decreasing interval, there's only one, it's right here. And if I look horizontally, it starts here at three, then it goes to about 2, then 1, then 0, then -1, then -2. All the way, looks like it's getting smaller and smaller and approaching negative infinity going to the left. Remember, we have to look from left to right. So it's going to go from negative infinity to 3 with a bracket. And there's a bracket there because closed circles get brackets. Alright, it is definitely not 1-to-1 because it doesn't pass the horizontal line test. And there are no axes of symmetry because this is not absolute value, and it is not ooh, wow, I'm getting tired. It is not absolute value or parabola. Alright, here we have Super Squirrel again, and Super Squirrel says, last graph, are you good? Do you get it? And he says that you are super. Alright, so this is our last graph, easy graph. It's an M and B graph. So M is 3/4, B is -2. So we're going to start down at -2 and count up 3 over 4. Up 3 over 4. And then connect your dots to make a beautiful straight line. If you notice, this is a great graph because it's going up and to the right, down and to the left in all directions. So that means that your domain and your range go from negative infinity to positive infinity. It is definitely continuous because I never have to pick up my pen to go up and down the line. There are no maximum or minimum values because remember, there's nothing that I can measure all the way up here, and nothing that I can measure all the way down there. This graph is constantly increasing. It's increasing, increasing. It's constantly going up. So because this is an increasing graph, it's increasing everywhere from negative infinity to positive infinity. This graph never decreases, so there is no decreasing interval. It does pass the horizontal line test. So yes, it is going to be 1-to-1. And we have no axis of symmetry, because that is only for absolute value graphs and parabolas.